The average rate of change, we had that formula is the change in y's over the change in x's. We had the y2s minus y1 over x2 minus x1. That was our rate of change formula or slope formula. So for our objective today, it says I can find the average rate of change from a square root function, and we're going to have context problems today. So for prior knowledge here, it says to find the slope of the line that passes through the points 128 and 452. So if you remember, the first value is the x's, so like the x1 and the x2. The second value in the coordinate are your y's, so that's the y1 and the y2. And our formula is y2 minus y1 over x2 minus x1. Okay, you have the four values, you just plug them in, set up your fraction. After you set it up, you subtract them, and then after you subtract them, you divide to get your approximate answer there. Okay? So minus here and a minus here. Subtract them to get a new fraction, and then divide them to get your final answer. And this is a prior knowledge. You guys should be able to do this, so I'm gonna let you guys just do it, and then we'll check after. Okay, so here's the solution again, was 8. So for concept, we have the average rate of change is the average change between the y values for each unit of x. That's why you do the change in y's over the change in x's. You subtract the y's over the x's subtracted. And then it goes on to say the average rate of change for the interval corresponds to the slope of the line that passes through the 2 points at the ends of the interval. And this line is called the secant line. You don't necessarily really need to know that for now, but it comes useful when you get to like a calculus and pre-calculus. You guys start to talk about secant lines and tangent lines. But for the sake of Math 3, we don't really need to necessarily know what a secant line means. Okay. So we have the formula here, the average rate of change, and then for some reason my computer doesn't read this, but that's supposed to be triangles in front of that. That's the change of f of x over the change in x. So the formula is the change, and then that little triangle means the change in f of x over the change in x values. So we subtract the two functions values over the x's subtracted for the interval x1 and x2. But if you guys remember our function notation, f of x is the same thing as y, right? So this formula is exactly the same as the y2 minus y1 over x2 minus x1. The other one is just in function notation because we're talking about square root functions. But for simplicity, we can just call them y's instead of f of x's. It's the same thing, okay? All right, so if we look at our first example here, we have a picture of an elephant, and then it says the shoulder height h. So the shoulder height h in centimeters of a particular elephant is modeled by the graph of the function below, where the age of t is in years of the elephant. And then it says to include units in your final answer. So just so you understand what this is talking about, it's you measure from the floor to the shoulder, like the top of the shoulder for the elephant. That's how they measure the shoulder height, from the floor to their shoulder. That's their height, okay? And so we see the graph for the elephant here, the ages in years. So when the elephant is born, when a particular elephant is 10, 20, 30, 40, 50, 60 years old, and so forth. Okay. Part A is asking you to approximate the average rate of change over the interval from 0 to 20. So 0 would be right here, my x value of 0, and an x value of 20 gets me to this value up there. Okay, so we need to first determine what our coordinate points are going to be. So this is going to be 0, comma, something else. And then this one right here is going to be 20, comma, we have to estimate the y values, okay? So to estimate the y values, if you notice, 2 units in my scale for the y is 65. So for 65, if I cut 65 in half, that would give me my first unit right here. So what's 65 divided by 2? Can you guys do that in the calculator? 32.5, right? I'm going to zoom in so you guys can see the graph a little bit better. Again, 2 units is 65. So to get to 65, I cut it in half, and that gives me the 32.5. So now I know my scale is a 32.5. So looking at the 0 coordinate point right here, it's between 65 and like, what's that, like 97.5, I guess? So between 65 and 97.5, it's there. Do you guys think that's the halfway point, above the halfway, or below the halfway? Below, right? It's below the halfway, and because our scale is going almost by past 30, every like little increment is gonna be like the halfway point would be like 15, and then halfway, like the quarter point, would be a 7.5. So let's just say for sure that's under the halfway point. Let's just say that's 5. So 5 units above 65 would give us to what? 70. Let's just make it easy and say that's 0.70. My 20, that kind of looks like it's the halfway point. That's almost 30. So what's half of 30? 15. So then take 260 minus 15 to get to the middle. What's 260 minus 15? 245. So this is approximately 245. And it's just an estimate. It doesn't have to be exact because we're approximating. We're estimating because we don't really have a very precise scale. We're estimating anything in between like 32 points right there. All right, so again, the first value is going to be our x's. So x1 is 0, x2 is 20, y1 is 70, and y2 is 245. So for my formula, take the y's, y2 minus y1 over the x's, x2 minus x1. So just like we did for the prior knowledge, you subtract the y's. So we get 245 minus the y1, which is 70, over the x2, which is 20, minus x1, which is 0. Okay? So go ahead and find a new fraction for me. When you subtract, what do you get? And then once you subtract, tell me what is the final answer after you subtract. When you subtracted, what did you get, Fatima?
175 over 20.
Over 20, thank you. And when we divide, your final answer, Alexa, as a decimal?
8.75.
8.75. Thank you. And then the directions say to include units in your final answer. So to determine the units, notice we're subtracting the y's over the x's. So for my units, I need the y's over the x's. So if I look at my context over here, my y has a unit of centimeters and my x has a unit of years. So when I write my fraction, this is going to be the y's units, which is centimeters, over the x unit, which is years. Okay? So my units for my final answer should be centimeters per year. You don't have to write a sentence, but you need to be able to write your answer with units. But what this is representing is from 0 to 20 years. So the first 20 years of life, I can see it grows kind of gradually, very kind of, I guess, fast in the beginning of life, the first 20 years. It grows about 8.75 centimeters every year in the first 20 years of life. Okay? All right, now part B, still same context, but part B says approximate the average rate of change in shoulder height of an elephant from 20 years to 40 years of age. And then it says to round to 3 decimal places if necessary. So notice this time is going from 20 years to 40 years. So from 20 to 40 now. How fast is it growing between those 20 years there? Okay. So my x1 is 20 and x2 is 40. So now I need to determine my 40, which is up here. This value, is that on the line or below the line? At the 40, what do you guys think? It's right below the line, right? You guys told me the scale is 32.5. So I need to figure out what this value is right here, because then that value is right below it. So you're going to take the 260 plus 32.5 and see what you get there. 260 plus 32.5 is going to give us approximately what value? 290 what? Are you guys adding? Take your calculator. 260 plus 32.5. 292.5. Thank you. So the next box is 292.5, and that's like right below it. It's like slightly underneath it. So what do you guys think that value is going to be?
Did you say that answer is 2.5?
The 32.5. Because one whole box is 32.5. So you add 260 plus 32.5 gets you. Yeah, sorry. Okay. And that's like right underneath the 292.5. So what do you guys think this value is going to be? We can just estimate it to make it easy. Let's just say that's about 290. You could say 292, you could say 291, but just to make it easy on us, let's just say 290. All right, so to set it up, I'm going to take my second y value. So now this is y2, and this becomes y1 now, because we're looking at a different interval. So I'm going to cross this out because now I'm looking at a different interval. My 290, my 290 is y2, and 245 is now y1. 40 is the x2, and 20 is the x1. So go plug them in and subtract. Set up your numerator, subtracted the y's, and the denominator with the x's subtracted. find your new fraction after you subtract. And then the final answer as a decimal. Not here. Jose's not here. Ajay. Simran, can you set it up for me, please? How did you subtract?
290 minus 245 over 40 minus 20.
40 minus 20. Awesome. Thank you. Okay, and then when you subtracted, what fraction did you get? Tomar's not here. Omar, when you subtracted, what did you get?
I got 45 over 20.
Thank you. And then for the final answer, Isabella's not here. Ashley, the final answer, what did you get? 2.25. Thank you. And then my units should be what? Carmen? Centimeters per year. Awesome. Thank you. You take the Y unit over the X unit. All right, good job. So notice from the first 20 years of life, from 0 to 20 years, it's growing about 8 centimeters every year. But then from 20 to 40 years, that's another 20 years. In the next 20 years of this elephant's life, it only grows about 2.25 centimeters. Notice it starts to grow still, but slower. In the beginning, it grows kind of really fast, and then in the next 20 years, it's still growing, but it's not growing as fast as it used to. Okay? And that kind of makes sense if you think about us as human beings from when we're little to like our first 10 years of life. We grow really fast, right? But then between 10 and 20 years, we don't really grow that fast anymore. Sorry. So the first 10 years of life, we get like a growth spurt, right? And then we're like growing. And then like as a teenager, you don't grow that much. And like you do grow, but not as fast as you did in the first 10 years of life, right? You're still growing. And then like females, we stop growing like between the ages of like, I think 17 to 19 or something is when a female stops growing. And then a male stops growing between the ages, I think of like 17 to 21. A male like stops growing roughly between 17 to 21 years old. We're still kind of like growing very, very, very little, but like we're kind of start to level off. And so that's why in our graphs here, we can see it grows kind of fast in the beginning and then it starts to level off and you're still growing, but like very slowly. And then at some point in our lives, they say you start to shrink again. So like, when you get older, you start to like shrink, supposedly. I don't know if that's true, but anyways, so we can see this in elephants too. They grow kind of fast in the beginning and then they start to level off and they don't grow as fast anymore. Okay. So for this next one is a practice problem. You guys are going to now approximate the average rate of change over the interval between 40 and 60. So we need our 40 and we need our 60 coordinate points here. Thank you. So 40, what did we get for 40? It's not on my screen anymore. What did we estimate 40? 290. Thank you. Our 60 is right underneath 325. It's underneath the 325. So what can we estimate the 60 to be? Like 320? We'll say roughly 320. Okay. So now you're using those two coordinate points to find the rate of change. Take your y's and subtract them over the x's subtracted. Subtract those to find your new fraction and then divide to get your final answer. And then you're supposed to round to 3 decimal places. So after the decimal, 3 numbers. Okay? You guys go ahead and do this one, and then I'll call people again. Carlos, can you set up the fraction for me? How did you subtract them?
I put 320 minus 290. And then I did 60 minus 40.
60 minus 40. Awesome. Thank you. When we subtract, what fractions do you get, Jasmine? Though after you subtract, what did you get for your fraction? 30 over 20. Thank you. And then what do we get for our answer, Aaron? 1.5. Thank you. And our units, Deb? Centimeters per year. It's always the y's over the x's. Awesome. Okay. So far so good, right? It's not too bad. It's not like I don't think a difficult lesson, just because we've done this before many times. So hopefully it gets better every time. So that's so far I was looking at graphs. Now let's look at it from a table. But notice our table doesn't have the y values. We're gonna have to use something to find the y values here. So the context says that the speed in miles per hour of a tsunami can be modeled by the function s of d equals 3.86 times the square root of d. And it tells you where d is the average depth in feet of the water over which the tsunami travels. And then it says be sure to include units in your final answer. And again, you don't have to write a sentence, but at least be able to write units. Part A says to complete the table for the given depth values and then round the table values to the nearest tenth. Nearest tenth is that after the decimal one value, okay? So talk to your partner. What do you think we're going to have to do to find the S values here? What can we use from the word problem that will help us find the S values? Lefties, tell your partner, what do you think we're going to use? Okay. I'll do a volunteer. Volunteer. Does anybody want to tell me? Alexa, thank you.
The equation right, that's right there, 3.86.
Okay, good. We need this function that's given to us. The s of d equals 3.86 times the square root of d. We're going to need this function to find s by plugging in these d values into the function, okay? So my function that I have is s of d equals 3.86 times the square root of d, okay? So to find our s values, we're going to take all of these d values and plug them into our function right here, okay? Everywhere you see a d, you're going to plug in the d values, which is 1,000, 2,000, 3,000, 4,000, and 5,000, okay? So this is going to be 3.86 times the square root of d, which in the first one is 1,000, and that's going to equal your s value. So to calculate that, you're going to use your calculator. You're going to put 3.86, and then you need a square root. So the square root, you go second x squared, and then you plug in 1,000, and you press equals. So everybody grab your calculator, plug that in. 3.86 second x squared 1,000 equals. Double check with your partner. See what did you get for your answer. To the nearest 10. So after the decimal, what number? Okay. What'd you guys get?
122.
0.06, so I'm going to run that to 0.1 because it says to the nearest tenth is one number after the decimal. Okay? 122.1 miles per hour. Okay? So you're going to keep doing that down the table, but you're going to change the D value every time. So this is now going to be 3.86 times the square root of 2,000. 3.86 times the square root of 3,000. And then 4,000. Then 5,000. So go finish the table, go find the other 4 values, and then I'm going to call people to tell me what did you get for your values. All right, so here are all of the S values, but the S's, remember, are kind of like our Y's. So now part B says to approximate. I know we're kind of short on time, but we can finish this one, and then this will be the last example for today. But approximate the average rate of change over the interval from 1,000 to 2,000. It's basically the same. 1,000 is x1 and 2,000 is x2. So I look for the table. This is my x1 and x2 is 2,000. So the ones next to it are the y's. So my y1 is 122.1 and y2 is 172.6. Okay? So I'm going to take the y's, 172.6 minus 122.1 over my x's of 2,000 minus 1,000. So if we subtract those, can you guys subtract those for me? I know the denominator is 1,000. You guys get 50.5?
Yeah.
Okay. And then divide 50.5 by 1,000. You get 0 point something. 505, so 51. We're just going to do 3 decimal places. 0.051. And then we need to talk about the units. So remember, it's the change in y's over the change in x's. So what's the y unit? Look at the y variable, it's miles per hour. The x units is feet. So this is miles per hour per foot. So my unit is miles per hour per foot. Okay? So we're going to go ahead and stop here. We're going to finish this lesson tomorrow, and then we'll work on the assignment in class tomorrow. So